All right, continue from the previous video. So if an alkyl halide already have a good leaving group, you can do an SN2 reaction on it easily, right? But the problem is if you want to do an SN2 reaction on an alkyl halide that has a bad leaving group or poor leaving group, what do you do? Okay, I'll review real quick. So halides are good leaving group. You guys know that iodide, bromide, chloride, because hydrochloric, the conjugate acid, hydrochloric acid, hydrobromic acid, and hydroiodic acid, they all are a strong acid. Okay. Now, anything that look like sulfate, also a good leaving group. For example, so we have mesylate or MS. The first oxygen here, that's the first oxygen there, right there, right? MS group is just sulfur to oxygen and a methyl. Right, so it's methane sulfonyl group. Right, this guy right here. The whole thing we call mesylate. Right. Now we have toisolate. We have toluene sulfonyl. So this is toluene. This is sulfonyl group, and we have the oxygen there, which is oxygen there. Okay, we call the whole thing here toisolate. And even the better leaving group. So mesylate is already good, already good. Toisolate is even better. And this guy right here, tipflate. Right, trifluoro. I don't remember the name. Anyway, so the whole thing we call tipflate. When this guy leave, you get a negative charge on oxygen. And if you still remember, fluorine is highly electronegative, and this guy got 3 of them. Help stabilize the negative charge through inductive effect. Okay, so this guy even the best leaving group compared to these two. But all is good, all is good. The whole thing here, the box here, this is a good leaving group. All right. Let's say if you do an SN2 reaction with an alkyl halide who's already have a good leaving group, it's good. It's easy to do. Add nucleophile, you get the product. But if you want to do an SN2 reaction on an on a compound that doesn't have good leaving group, this is a poor leaving group. You still remember, right? It's conjugate acid. It's water, which is pKa 16. This guy's the worst leaving group there. Okay, so how do you do that on this guy? Well, so we have to convert an OH to a better leaving group. And here's how we do it. You can add the hydrochloric acid, hydrobromic acid, and hydroiodic acid to replace OH with its halides. All right, so it looks something like this. So you add right here. We will talk about the mechanism later in the alcohol chapter, so not there yet. Anyway, so an OH, you can add a hydrochloric acid in there. So you replace OH with a Cl. You get that, right? So Cl going to be a good leaving group now, and you're going to add a good nucleophile and do a regular SN2 reaction. Another way you can do this, so you can use toisyl chloride, right, which is a toisolate group up there you saw earlier. So the alcohol will attack sulfur. This is how it works, and chlorine leaves. You're going to get OTS onto your compound, and then which is a good leaving group, and then you add a nucleophile onto it. Ta-da, and you get the product. Okay, this is an ester. All right. So this is how we synthesize an ether. This is how we synthesize an ester. Okay. Anyway, so my point is you can convert a poor leaving group to a better leaving group by using hydrochloric acid, hydrobromic acid, or hydroiodic acid. Or more common way, we use toisyl chloride. Okay. All right. All right, let's take a look right here. So which alkyl halides undergo substitution reaction with the fastest rate? Well, we have to look at the leaving group ability, right? Hydrobromic acid, hydroiodic acid, probably the best leaving group out there, right? Compared to other halides, right? In this case, so they are all secondary, the same thing. But now it's gonna be so the tiebreaker is gonna be the acidity of their conjugate acid, right? Hydroiodic acid is the best. Not the best, the most acidic compared to the bromine, chlorine. So iodine is the best one to see. What else we got? This one. Identify each position where an SN2 reaction is likely to occur when treated with hydroxide ion. All right. Now, if you remember an SN2 reaction, what do we need? We need less bulky substrate. All right. Tertiary, no. Anything, the halide on a double bond, no. Those two are no. all right? And the leaving group have to leave, so they're going to be a good leaving group. All right, look at right here. Start with this position. This guy is a good leaving group. This carbon right here is a primary, all right? One more time, primary means this carbon connect to another carbon, so connect to another carbon, so we call it primary. So this is one of the best substrate for an SN2 reaction. So yes, that position, good. Now, what about chlorine right here? So bonded to chlorine is a good leaving group already, so we're good. Now, look at the substrate, type of alkyl halide. This is also primary because it's connected to another carbon, so another position. SN2 can attack right here. All right, this chlorine right here, good leaving group already, but it connected to tertiary alkyl halide. So 1, 2, 3 connected to 3 more carbons. So we call this position tertiary alkyl halide, which is a bad substrate for an SN2 reaction, sterically hindered. Okay, so no, we don't do SN2 on here. Bromine, good leaving group, but tertiary alkyl halide, so no either. All right, iodine, one of the best leaving group, but connected to tertiary alkyl halide. No. Amine, NH2, good or bad leaving group? Think back to a pKa on pKa table. What's the pKa of its conjugate acid? What's the conjugate acid? NH3 ammonia. What's the pKa of ammonia? 38, right? 38. Oh my God, ew. That's really bad. The good leaving group is conjugate acid should have the negative pKa value, right? This guy have 38. I don't know what to say, man. It's really bad right there. So no, this guy never leave. All right, so no. Now, what about this guy? Me is a metal, right? CS3O. Well, what's the conjugate acid look like? An alcohol, a methanol, CS3OH, and alcohol. What's the pKa of an alcohol? 16, right? 16. This is bad leaving group. Water, alcohol about 16, water 15.7, around that, right? So this is a bad leaving group. Although this is primary, good substrate, but this guy never leaves, so you cannot do an SN2 reaction on it. This is how we think about it. All right. It takes some time. Practice some more on the study guide, and you'll be good. Okay. Who can do SN2 reaction? Who cannot? You should be able to differentiate them. And the double bond, if you see a leaving group on the double bond, that's a no-no. All right.